Hello girls, I hope you are staying safe at home. To continue with electrolysis chapter, we come to the almost the end of the chapter. Okay, so we will start with application of electrolysis. Now, electrolysis have many uses, technical as well as commercial applications. First is electroplating with metals. Next is electro refining of metals, and next is extraction of metals, which is known as electro metallurgy. Now, electroplating. What is electroplating? It is a process where a very thin film of a metal like gold, silver, nickel, chromium gets deposited on another metallic article with the help of electricity. You must have heard of, gold plated ornaments. Okay, all these artificial gold look-alike ornaments, what do they have? They only have a very thin film of gold. Similarly, it may be silver and so on. Okay, now what are the reasons for electroplating? First is decoration purposes. For example, brass objects, brass is cheap, so they are plated with silver to give them a shining appearance and beauty of a silver article. So when brass is electroplated with silver, it becomes very lustrous, it shines, and it looks like a silver article. And next is to protect from rusting and corrosion. Iron tools, instruments are often electroplated with nickel, chromium, or zinc to protect against rusting. You can see the normal, the iron that we use to iron clothes. You will find a layer of zinc that is coated over it. Now, what are the conditions for electroplating, children? This table is very, very important, and this is your assignment for this upload. Also, you are going to write down this table. Okay, so first condition is the article to be electroplated is always placed at the cathode. Okay, why? Because during the electrolytic reaction, the metal always moves towards the cathode. Okay, plus to negative. So as a result, you know that the metal will be deposited at the cathode. How? When it gains electrons. Now, the metal to be plated on the article must always be made the anode. So with whichever metal, supposing you are electroplating with gold, you will make gold the anode. Okay, and it has to be periodically replaced. Why must it be periodically replaced? Because the ions will continuously form in the electrolyte. Gold ions will continuously dissolve and it will move towards the cathode. So the gold slab or with whatever you are electroplating will get finished up. So it must be replaced from time to time. Okay, and I already told you the reason. The metal anode continuously dissolves as ions in solution and it must be replaced periodically. Now the third is the electrolyte must contain ions of the metal which is to be plated on the article. Like electrolyte, okay, must have the ions of the metal which is to be plated on the article. That means if we are electroplating with gold, okay, the electrolyte must also contain gold ions. Okay, and it must be a suitable salt of the plating metal. Why? The reason I already told you. The electrolyte dissociates into ions of the metal which goes towards the cathode and they are deposited as neutral metallic atoms on the cathode. And then another thing you must keep in mind is you must pass a very low current for a longer time so that there is equal distribution of the metal in the cathode. Okay, so because why? If we use a higher current, what happens? It causes uneven deposition of the metal, and longer time and low current shows a thicker and uniform deposition. And remember, children, a direct current must always be used, not alternating current. AC current means alternating current. Alternating current causes discharge and ionization to alternate at the cathode, thus giving no effective coating. So the coating will not be done properly. Okay, now how do we electroplate an article with silver? Electroplating an article with silver. Now, in order to get a perfect deposit of silver on an article, supposing you want a brass spoon to look like a silver spoon. So first thing you must do is you have to clean the spoon properly. You must wash it in a hot solution of caustic soda, and then you have to wash it in dilute hydrochloric acid and water. It is now very clean. Okay, after that we wash it with detergent and several times with distilled water. Then the spoon must be totally dried, and then you know the spoon is the cathode, because it is in the cathode where the silver will come and deposit. Okay, now this is the electrolytic cell. Okay, so what do you take the anode? The metal which is to be deposited at the cathode. So since we are depositing with silver, we take a block of pure silver as the anode, which is connected to the positive terminal of the battery. Okay, and then the cathode, we make the article to be electroplated. Okay, please always remember, children, the cathode is the article to be electroplated, and anode is the metal with which you are electroplating. And then what solution do we take? Sodium argentocyanide. Okay, so this is the formula. So the electrolyte you have taken is sodium argentocyanide or potassium argentocyanide. Argento means silver. Okay, now sodium silver cyanide, how do we prepare it? But we add sodium cyanide to a solution of silver nitrate until the precipitate formed just starts dissolving. Okay, so this is the reaction by which the formation of sodium argentocyanide takes place. So now in the electrolyte, what are the ions that you see? Sodium, silver and cyanide. From water you have hydrogen and hydroxyl. Now cathode, you already know, it is to the article to be electroplated, cleaned, and then it is placed there. Okay, so here what happens at the cathode? From the electrolyte, silver ions will move towards the cathode, towards the negative terminal, okay, towards the negative electrode, and it gains the electron it had lost, and it will turn into a silver atom. Okay, and what happens at the anode? You know, at the anode there is a plate of pure silver, clean silver. So at the anode, silver metal will lose electron very easily, since it is lower in the activity electrochemical series, and it will form silver ions which will go into the electrolyte continuously, and it will migrate towards the cathode. Okay, so the negative ions, that is cyanide and hydroxyl ions, migrate towards the anode, but they are not discharged. You know that, because we have active electrodes. So the atoms of the anode, that is silver, loses electrons more easily, and it passes into the solution as silver ions due to the nature of the anode, because it is active. So silver ions are attracted to the brass spoon, which is the cathode, and here they are evenly deposited, and the brass spoon will very soon turn into a silver spoon. So as I've already told you, how thick the coating will be on the brass spoon depends on the duration of the current pass. That means how long you have passed the current. And you know, in the process the anode dissolves, because the silver block continuously is changing into silver ions, and the electrolyte solution maintains the same concentration. So if it is colored, the color will remain the same. Okay, now the spoon then is taken out of the bath repeatedly, washed several times with water, dried and polished. So you take it out, you dry it, you wash it, and then you polish it, and then there the brass spoon turns into a silver spoon. Now remember, children, if silver nitrate solution is used directly instead of double cyanide of sodium and silver, the deposition will be very fast and not very smooth and uniform. It will take place very fast, but it will not be smooth and uniform. Okay, so that is why we do not use silver nitrate solution directly. So you'll get this question in your explain why. Now next, moving on to electroplating with nickel. Iron gets easily rusted when it is exposed to air. You know that, because when it comes in contact with air, with oxygen, and if it is moist, the iron will turn into rust. Okay, that is iron oxide. So if iron articles are coated with a metal like nickel, tin, or zinc, rusting can be prevented, because the air will not come in direct contact with the iron, because there is a coating in between. So if nickel plating is to be done, the iron article whichever is coated will always be made the cathode. I had told you to keep in mind. Okay, article to be plated, the iron, it is the cathode to the negative terminal of the battery. And since we are electroplating with nickel, nickel is made the anode, that is connected to the positive terminal, or it is the positive electrode. Okay, and the solution, what do we use? Nickel sulfate. It has to be there, because nickel, we are electroplating with nickel, so nickel ions must be there in the electrolyte. So and of course a little bit of dilute sulfuric acid is used, so that the conductivity of the electrolyte increases. Now what is the electrolyte? Nickel sulfate. So nickel sulfate dissociates into nickel and sulfate ions. Water will dissociate into hydrogen and hydroxyl ion. And as I already told you, article to be electroplated is cleaned and placed at the cathode, and anode is the block of pure nickel metal, because this has to dissolve, okay, and form the ions, and continuously it must be given in the electrolyte. So what happens at the electrolyte? Nickel, it gains the 2 electrons it had lost and turns into nickel atom, that is the metal which is deposited at the cathode. Okay, and nickel ions are discharged at the cathode as neutral nickel atoms by gain of electrons in preference to hydrogen ions. Okay, now at the anode, what happens? The nickel metal will lose 2 electrons and turn into nickel ions, which is continuously given into the electrolyte. Sulfate and hydroxyl ions, they will migrate towards the anode, but they are not discharged. Why? Because the electrode is active. Okay, so the nickel anode loses electrons to give nickel ions in solution. And please keep in mind, I've already told you also, article to be plated is always kept at the cathode. The electrolyte must be a solution of the salt of the metal to be electroplated. Okay, we saw both in the case of electroplating with nickel and electroplating with silver, how the electrolyte contains silver ions as well as nickel ions. Okay, so the anode is made of the strip of the metal to be plated. This is very, very important. These 3 points you must never forget when we are talking about electroplating. Another application of electrolysis is in the electrorefining of metals. Now, when we're talking about electrolytic refining, we're talking about a process by which certain metals which contains impurities are made pure, 100% pure, electrolytically to give a pure metal. Okay, now refining of copper. The most important use of copper is in the use of wires for electric transmission. So for this, you remember, children, that the copper must be very, very pure, because even a small amount of impurity reduces its conductivity to a very great extent. Okay, so the electrolytes, remember, must always contain the ions of whatever you are electrorefining with. So here what do we use is a solution of copper sulfate and dilute sulfuric acid is used to increase the conductivity of the electrolyte. And the cathode, it is a thin strip of pure copper. It is over here where the copper ions will migrate and then it will be given out. Okay, and anode is the impure copper. Now, when the current is passed through the electrolyte, the copper ions of the copper sulfate, they move towards the cathode, where they gain electrons and get deposited on the pure copper strip. So what happens at the cathode? copper ions gain the 2 electrons that they had lost and turn into copper atoms, which is deposited at the cathode on top of the pure block of or pure strip of copper. And what happens at the anode? Impure copper is there, so the copper from the impure block dissolves, okay, and turns into it loses 2 electrons and turns into copper ions. So continuously what happens? These copper ions, it will migrate towards the cathode, okay, one after another, and then it will gain electrons at the cathode and gets deposited in the cathode. So what will happen is the impure slab of copper gets finished and the thin strips of pure copper become thicker and thicker. So the copper deposited on the cathode is 99.9% pure. After the electrolysis is over, these strips are melted and then it is transformed into whatever they want it to be. Either they are made into wires or maybe utensils, okay. Now some impurities get dissolved in the acid, while others like silver, gold, which are insoluble, get collected near the anode, and it is known as the anode mud. And then they are also recovered. Why? Because they are also metals. So when all the copper gets dissolved in the electrolyte, what remains behind, it will get collected as the anode mud, and of course they are also collected, okay. So metals like zinc, lead, mercury, silver and copper are refined by electrolysis. Please remember these names of the metals, okay. Next we come to electrometallurgy, okay. You'll be learning more about metallurgy in the next chapter, okay. So when we talk about electrometallurgy, we are talking about the process of extraction of metals by electrolysis. Now metals which are higher in the electrochemical series like potassium, calcium, sodium, highest in the electrochemical series, okay, there's magnesium, aluminum, they are extracted using electrolysis. Why? Because these metals have a strong affinity for oxygen. They will react with oxygen and the oxides are highly stable. It is not like easy to remove the oxygen from the oxides. So we cannot reduce the oxides by common reducing agents like carbon monoxide or hydrogen. So the only way to extract these metals is by electrometallurgy. So reactive metals are extracted from their halides, chlorides, bromides by electrolysis, and it is also known as electrolytic reduction. Why? Because we are removing the metal, okay. And what type of electrodes do we use? We use inert electrodes. So remember children, cathode is made up of iron and anode of graphite. Now reactive metals are not extracted from the aqueous salt solutions by electrolysis. This is because aqueous means it will contain hydrogen ion from water. Aqueous means from water, it is dissolved in water along with the metal ion. So when we pass electric current, the hydrogen ion will get discharged in preference to the metal. So we should always use the electrolyte in the melted or molten form, okay. For example, potassium electrolyte is fused, potassium bromide. Fused means melted, okay. So you know that potassium bromide will turn into potassium and bromide ions. So what happens at the cathode? Potassium will gain the electron it had lost and it will turn into potassium metal, and at the anode bromine will lose electrons it had gained, so it will turn into bromine atom. Two bromine atom will come to form bromine gas, reddish brown gas. So potassium metal is obtained at the cathode. Similarly, electrolyte for extraction of sodium, we use fused sodium chloride, melted, okay. So sodium chloride will turn into sodium and chlorine ions. So at the cathode the sodium will migrate and it will gain one electron it had lost and turn into the sodium metal. And at the at the anode, the chlorine will lose the electrons that it had gained and turn into chlorine atom, and two chlorine atoms will come together to form a greenish yellow gas, that is chlorine at the anode, okay. And sodium metals are always obtained at the cathode. Now magnesium Again, fused magnesium chloride melted. So what are the ions? You'll get magnesium and chloride ions. So at the cathode, the magnesium will migrate and it will gain the 2 electrons it had lost and turn into magnesium atom, neutral magnesium atom. Okay, and at the anode, the chlorine will migrate and it will lose the 2 electrons it had gained and turn into chlorine. 2 chlorine atoms will come together to form a greenish yellow chlorine gas. Magnesium metal is again obtained at the cathode. Okay, aluminium is obtained by electrolysis of its oxide alumina. This we'll be doing again in metallurgy chapter. Okay, so here gas carbon lining of electrolytic cell acts as cathode. Remember, gas carbon lining of the electrolytic cell only acts as the cathode, and graphite rod acts as the anode. So electrolyte, you already know, is aluminum oxide. Okay, cryolite. Okay, and fluorspar. We'll be doing this in detail in the metallurgy chapter as well. So reaction, you'll see aluminum oxide will turn into aluminum and oxide ions. So at the cathode, what happens? Aluminum will gain the electrons that it had lost to turn into aluminum atom, and at the anode, oxygen will lose the electrons it had gained to turn into oxygen atom, and the oxygen atoms come together to form oxygen gas, which rekindles a glowing splinter. Okay, so apart from that table I had asked you to do as the assignment, children, I would want you to draw and describe the electrolytic refining of copper. Okay, so this is for this week, so you submit it day after tomorrow. Till then, children, stay safe. God bless you.